Hello everyone, look over here. What do you see? Here we have an ice cream cone, a conical roof, a fire extinguisher in shape of cone and some DIY Christmas gifts. What all these shapes remind you of? Yes, very rightly. These are all cones. So today in this video we will study about cones, about the axis of cone, about right circular and oblique cones, and then we will understand the surface area of cone. Let us start with this. So basically, cone has one circular base and a conical surface. Cone has a base that is circular and a lateral surface that is conical. So in this conical surface, we also have a vertex. Vertex over here. Okay. So when we have understood what a cone is, now think about the axis of a cone. In the previous video, we have already talked about the axis of a right circular cylinder and oblique cylinders. So in case of cylinders, we said that axis is when you join the centers of bases, the line you get is the axis of cylinder. The similar case is with the cone also. So look at the cone. So cone has basically only one base. So how do you find the axis? So we can see that the base is circular and with circle comes center. So find out the center of the cone and join the vertex with the center. And here you have the axis of this cone. Now this is the axis and around the axis the cone revolves. Now look over these two cones. Both of them are cones, but they seems a little bit different to each other. One of them is a right circular cone and the other one is a oblique cone or not a right circular cone. So tell me which one is a right circular cone? Oh yes, this one is the right circular cone. And now how will you identify it? So we will see that if we draw an axis to the right circular cone, so here is the center, and when I join the vertex of a cone to the center of the base, I get the axis. So this is the axis of the cone, and now I'm going to make the diameter of the base. So basically I can see the axis and the diameter are perpendicular to each other. So this type of cone is called a right circular cone. And in the second case, I'm drawing the axis first. So this is the center. I'm joining the vertex of the cone with the center of base, and here I get the axis. This is the axis of this particular cone, and now I'm going to draw the diameter for the base. Okay, so this is the diameter, and now I can see that the axis and the diameter are not perpendicular to each other. They are not making 90-degree angle to each other. So this is not a right circular cylinder, right circular cone. This is called what? An oblique cone. The same way we talked about cylinders, this is a oblique cone. Okay. Now, here when we are going to talk about cone, we are talking about right circular cones. Okay. So, we will talk about surface area of cone. Again, the surface area of cone, we have two types of surface area, lateral surface area and total surface area. You already know. that the lateral surface area is the surface area excluding the bottom. Okay, and in the total surface area we include the base also. Okay, so here is the net of this particular cone. So if I cut this cone, it opens up like this, and here is the base circle. Okay, so to find out the lateral surface, I have to find out area of this part only, and when I have to find out the area of total surface area of the cone, then I will find out the area of both of these parts. Okay, so let us start with the lateral surface area only. So as I have already told you that to find out the lateral surface area, we are going to find out the area of this part only. Okay, before coming to this, let us once again take a look on this cone. So basically, in this cone, this is the center and this is the radius. And when I join the center and the vertex, this length, this particular length is called height. Okay, so this is the height. Now what is this? This is called slant height. Okay, it is very important to understand the difference between height and slant height of a cone, because when we were talking about cylinders, so look at the cylinder and make a axis. So this is the axis. So basically in cylinder, this is also h and this is also h, so they are both same. Okay, in a right circular cylinder, the length of the line joining two centers of the opposite bases and the height is same, but this is not the case with cone. In cone we have a slant height and have a height. Okay, these are different to each other. Okay, so you have to understand this. Now when I cut open this cone, this particular part is what? This is the slant height. Okay, so this is the slant height. This you have to remember. Now come to this. So I know this is the slant height. Okay, and what is this? This part. So basically when I had this cone, okay, so this part was what? The circumference of this circle, because when I cut this open, it became like this. So it is what? It is the circumference of this particular circle. Okay, and you know what the circumference of a circle is? It is 2 pi r. So basically this whole length is 2 pi r. Okay, now I don't know how to find out the area of this whole surface. So what I am doing, I am dividing this into small right angle triangles. So many triangles. Okay, I am dividing it like something like this. Okay, some straight lines. Okay, small lines. And so many more lines, something like this. Okay, and this is perpendicular. This length is perpendicular. Okay, so I am taking this triangle, then I will be taking this triangle, then this, and so on. So this is B1, this is B2. Okay, I'm just naming them something like this, B4, and so on. Okay, now I know that the area of triangle is half into base into height. Okay, so for the very first triangle, the base is b1 and the height is this L. Okay, so look over here. So the area of the first triangle is half into length into b1. Okay, length, why? Because it is the height. Okay, now come to the second triangle. Okay, for the second triangle, the base is b2 and it is not a right angle triangle, so the 90-degree angle is over here. So this is the height for this triangle also, and this will be the height for the each and every triangle we have made here. Okay, so L is always the height over here. So we are going to take it like this: half L into b1 plus half L into b2 plus half L into b3 plus half L into b4 and so on. Okay, so now I can see that half into L is common in each and every term of this. Okay, so I'm just taking that common half L, and in bracket I have now b1 plus b2 plus b3 plus and so on. Okay, so now what is this b1 plus b2 plus b3? Look over here. So this is b1, this is b2, b3, b4, b5, b6. So it is basically making this up. Okay, so I will add it till I get this whole length. And what is this length? I have already seen that this is 2 pi r. Okay, so in place of b1 plus b2 plus b3 and so on, I can write what? I can write half L into 2 pi r. And what I get from here? Pi r L. Pi r L. And this basically is the lateral surface area of cone. Pi r L. Okay, so this is the lateral surface area, pi r L. Now we have to find out the total surface area. So to find out the total surface area, what we are going to do? We are going to add this and that. Okay, so I have lateral surface area pi r L. I know this area of circle is pi r square. So just add them, pi r L plus pi r square. That gives you pi r is common, L plus r. So this is the total surface area of a cone. Pi r L plus r. Okay, so I hope you have understood it very well. Okay, please do like, subscribe.